And we have the obligatory awesome new hats. So thanks, Matthias and co. So we're going to start off with the traditional thing we do at JFocus, and that is to tell Matthias Carlson that he's awesome. But I'd like to change it up a little bit this year and actually have everybody in the audience all do it at the same time. So if we can just say on the count of 3 that Matthias Carlson is awesome, that would be really much appreciated. So 3, 2, 1, go. Matthias Carlson is awesome. Woohoo! Thank you. All right, so today Richard and I are going to cover off what we call the bleeding edge. It's sort of walking you through the journey we took at my company, jClarity, and the technology stack we designed and built along the way. And a lot of the lessons we learned in terms of how we made technology choices, how we implemented prototypes, and we sort of got a score sheet on all the various bits and pieces of technology that we used, some which were very good, Angular.js, and some which disappointed somewhat,
MongoDB.
So yeah, if you're looking for a scorecard to sort of wave at your friends and claim that one technology is better than the other, then, you know, as Richard said this morning in his talk, I think, the facts are up on slides, therefore they must be correct.
Yeah.
So this was very much the feeling I had when I first started jClarity, and we had to start thinking about building a modern technology stack with asynchronous messaging, which was a SaaS service on the cloud, distributed across the world, which had to be lightweight, low impact, and not ship too much network traffic. Now, I formerly came from quite a strong Java EE background. I did, Java messaging service, enterprise integration patterns, Spring, Hibernate, all that good stuff. So, I really got lost in this new world. This is who we are. So I'll let Richard talk about himself a bit.
So yeah, I'm a software engineer. I'm just back end of writing a book on Java 8 Lambdas, which is in early access if you want to go and buy a copy. And I occasionally do a bit of conference speaking as well.
Yep. I've been recently demoted to CEO, which means I don't do a lot of coding anymore. So this will probably be my last JFocus, and I'm going to go talk at trade conferences about, return on investment and other boring things. And the company that we both worked on together, Richard has actually moved on and is looking for new work potentially. So if you want one of the best Java engineers in the world, then definitely look up this guy. But we try and solve really difficult performance problems. We try and find where the performance bottleneck is in a system in real time. It's kind of a non-trivial problem to solve. So these are the 5 things we're going to cover. What the status quo is today in terms of picking technology choice. Then we're going to explain what we went and built, how we picked the technology, the scorecard, which is going to be everybody's favorite bit as we rip MongoDB to shreds. And then sort of talk about how you also can step into this brave new world and no longer have to use Spring and Hibernate for everything. Status quo. Who here recognizes this stack? We've got lots and lots of lovely enterprisey things. I see we have Corba. Always very important to have Corba when you write Hello World. We have security, we have transactions, we have lots and lots and lots of XML configuration, so on and so forth.
I think there should be a box somewhere for the kitchen sink. I can't quite see it though.
Yes, definitely need a kitchen sink. And I think if any of you have ever fired up a Java EE application server, your WebLogic, your WebSpheres of the world, I mean, this thing is a big, heavyweight, fat monster. And not necessarily ideal for solving modern problems. So we did have lots of experience in this field. I, to my shame, was actually a certified blah, blah, blah Java EE architect at some point. Both Richard and I have done work on the JCP, looking in at Java EE standards. And we won't claim we're deep dive domain experts, but generally inside the jClarity team, we were quite familiar with the Java EE stack.
And there's lots of compelling reasons why you might want to use that stack as well. It's just our particular use case didn't fit that kind of model.
Exactly, and we'll definitely go into that in a little bit. So yeah, so what if you're in the world where you can't use this traditional Java EE stack? So we'll show you the architecture of what we had to build in a second, but the idea is that we have these really lightweight, small, tiny Java daemons or processes that run on our clients' machines. So we can't run them inside a Tomcat on a client machine or a JBoss application server, because that would be, in the words, in not so polite words, crapping all over our clients' hardware and software. And clients don't really like that, funnily enough. So we will go into what we built. So what we're trying to build, or what we have been building, is, again, these little daemons that sit there, gather a small amount of metrics from your operating system and your JVM, and hopefully tells you exactly where the performance bottleneck is. So that's sort of the business domain. The sort of more interesting technology domain is that these little daemons can sit on any machine anywhere around the world, and the information they send back is to a central-ish dashboard, which we host as a SaaS service. So lots of two-way communication, lots of interesting challenges with doing things like living on Amazon's AWS, so on and so forth. This is kind of roughly the tech stack we chose. So we have on the client machines lots of these little Java daemons. We have two-way communications over an SSL socket. We use JSON as our lingua franca for that. And in our aggregator, we've not used the Java EE stack at all. Okay, so we're using a technology called Vertx. We're using things like both Groovy and Java in our stack. And of course, we've got MongoDB. And of course, Angular.js and friends. We probably have about 15 to 20 JavaScript libraries all wrapped up on the client. So pretty fun. So,
if you kind of look at the kind of things we're talking about, I mean, Martijn's emphasized the idea that the daemon that runs on other people's machines does need to be lightweight. I mean, the main reason there is that if you're trying to diagnose people's performance problems, you don't want to be the performance problem that you end up diagnosing. That's a bit of an embarrassment. It's also not very friendly to the customer. On the other side, we wanted our aggregators to happily sit there and monitor as many servers as we could get customers for. And you know, we wanted to be holding a lot of long-running connections, keep on monitoring these things, be aware of having events being pushed back from them whenever we wanted to. We wanted to have a load of non-blocking I/O, loads of long-running connections that may be sitting there. Perfect use case for this kind of situation. And on the UI, I mean, it's one of these things where, like, especially on the kind of startup front, you need to have something that looks flashy and has a really rich experience and really kind of friendly and that kind of stuff. But you also need to have something that's kind of browser-based, so your clients don't have to deploy yet another piece of software into their internal ecosystem to run your product. Yeah, I mean, so you want a kind of rich client browser-based app.
Yeah, without telling everyone to use Java Web Start or some other awful technology to deploy the application, which, you know, any sane security manager will just say flat out no to these days.
So, as we say, like, there's nothing wrong with the Java EE world in terms of for many application domains, but these are kind of things that don't really fit there. So, you know, a complicated, complete full stack EE container is really not a lightweight, low-impact application. It doesn't sit there quietly. And on the server, a lot of the EE framework fits into a kind of a request-response web page-based model, which again doesn't fit the kind of things we were looking at. And on the UI front, there's been some advances in EE7 on the WebSockets, but at the time we started working on this, that didn't really exist, it wasn't really mature, and there's still not that much kind of push event support or also kind of JavaScript client-side framework support for that kind of thing. So it's not necessarily a great way to be basing a rich client app on.
And even if it had been there, we still would have had to have a Java EE container to give us WebSocket support, because the WebSocket support isn't part of the core, you know, core JDK, core Java itself. So again, it's not an option for us. We can't tell our clients to go install Jetty or Tomcat just in order to run our little daemon.
So having said that we didn't want to use that technology, we've got to tell you how we picked technology or why we picked technology, which is actually quite a useful approach, I think, that's generally applicable outside of this situation.
Yeah, and I touched upon it a little bit in my talk this morning, but we're probably going to go into a bit more depth here in terms of how we go about do this. So thank you again, Matt Rabel, by the way. Yeah.
So,
why is there a moose in that picture?
Why have we got that picture? I think we've got that picture there because the point is, if you end up with a bunch of ingredients and you throw them all into a pot, you end up with the kind of Swedish chef from the Muppet situation where he's going crazy and going hurdy-gurdy and all the rest of it. And for some reason, you also end up with a moose in the background. I don't know why that is. But you do definitely, again, as I said, it's on a slide, therefore it's fact. You definitely end up with a moose in the background.
And I think we've now successfully completely insulted our Swedish audience. So bonus for Speaker Pro. So yeah, we've got a methodology which we sort of adopted from Matt Rabel, which he taught me probably 4 or 5 years ago now. And it's a pretty simple way to stop your technology team from, infighting all the time. And the key thing that we do with every technology choice we made in the earlier diagram we showed you was to identify what criteria was really important to us. So, for example, on the client, we said, okay, it's got to be lightweight, it's got to be able to push events, it's got to be JVM based, and it's got to be capable of reading information from the Linux operating system, as an example.
And it's not just a technical criteria either. It might be, are there books published on this? How easy can you get help? I mean, we conveniently know one of the authors of the Java MongoDB driver, for example, which means our ability to get help about MongoDB massively ups on our score. But there are all these kind of different facets which you might want to put in as part of your ranking criteria.
Yeah. So, I mean, we, even in some of the language choices we made, we looked at things like, or I would have to look at things like, is there a job market for people that are, proficient programmers in a particular language? I mean, it might be cool that we would want to, say, use Clojure or Scala across our entire code base. But if I can't find new engineers to actually work on that technology, that's a real concern for a business. But again, it's not always technical choices that you're making. So here's sort of our version in really awful handwriting, which is mine. I'm left-handed. I do apologize.
The bad handwriting isn't necessary for the successful application of the methodology.
Yeah. But as you can see up here, we've got a whole bunch of our criteria on the left-hand side. We were talking about our UI, UX choices for our browser-based UI. And we had some choices between sort of a Java effects, Scala effects, or groovy effects type thing, HTML5 and friends, and even Qt or Quit, I think some people call it. Qt.
Yeah, so we were doing a kind of ranking, a weighting for each criteria, like 0, 1, or a half, and you then multiply that weighting by the score you give for each rank out of 10, and then you add them up. Once you've added all the scores up, I mean, we only had 3 there because we started blackballing a lot of UI technologies really early on. Once you've got the scoring, you can start prototyping the top couple of choices. And even though prototyping may seem like, in some sense, you might view it as not being productive work. It might not be viewed as getting towards the end of your goal. As I'm pretty sure anyone who's realized, who's done software engineering for a bit, making a better technology choice can save you a hell of a lot of time in the long run. So it really is worth spending some time prototyping at this. I think we were looking at kind of a week per technology.
Yeah,
or
typically
a few days.
typically a week sprint. And I think in hindsight, maybe we didn't even spend long enough in some cases.
I think Matt Rabel actually has even partially recommended going up to 2 weeks for some technologies if it's a framework you're really, really buying into or really, really dependent upon.
We should have done 2 weeks with MongoDB for sure.
Yeah.
So, some observations about our approach. It is still a subjective approach. I mean, you're not taking empirical science measurements here in a peer-reviewed journal and all this sort of stuff. And there's no guarantees you're going to get the right technology at the end, but you certainly have improved your chances significantly. It's got some incredible pros. It actually really does include the whole team in the decision making, so it's a great way to have every single engineer and QA person and ops person, if they are separate functions, to really have a stake in the ground and really be part of the overall architecture and really believe in it, as opposed to having it dictated to you from way on high. Which I think we've all seen at a number of organizations.
Avoid the enterprise architect.
We hate the enterprise architect. If you're an enterprise architect, please leave. So on to the fun part of the talk, the technology scorecard. So we're going to go through about 5 or 6 different technologies, the pros and cons of each of them as we discovered them. So this is really kind of a boots on the ground. We probably didn't have a lot of initial expertise in any of these technologies. And we're kind of going to give it a scorecard in terms of how we found it over the sort of 18 months.
Yeah.
And here's the tech stack we have. So just as a reminder, we used Angular.js, we used Bootstrap, some Groovy, some Chef for our DevOpsy stuff, MongoDB web scale, and a very cool technology called Vertx, which Richard will go into some more deep dive detail about.
Yeah, we ended up being pretty startup hipster technology compliant for our tech stack in the end.
We certainly are.
Despite the...
And again, notice there's no Java EE in there, no typical enterprisey sort of stuff. You know, we've got no LDAP, no JMS messaging stuff, none of that sort of nonsense. So another reminder as to what our tech stack architecture looks like, just as a quick overview. So we've got little Java daemons on the client, and on the service side, which is what we host ourselves, we have this sort of distributed cluster of aggregators which run Vertx, Groovy, Java, MongoDBs, and for the UI, Angular, Sock.js, Bootstrap, and Friends.
And the daemons were pretty much core Java as well.
The daemons are just core Java, yep.
So Angular.js, I think it was actually a talk about Angular at JFocus, right?
Yeah, I think so.
Which is a client-side JavaScript framework. So, a lot of people are kind of very familiar with MVC type stuff where they just generate HTML as their view, whereas things like Angular.js take the approach that you put a lot more of your logic, a lot more of your code into the JavaScript side of things. You end up with a lot more of your domain modeling on the client side, you end up with a lot more code on your client side, but it's also quite good for building rich client apps that have quite a good, nice user interface. They seem to be reasonably agnostic as to whether they're model view controller or model view view model. I won't really go into the distinction between the two, but it's kind of, they're quite flexible about that kind of thing and unopinionated. The real win there is what's known as two-way data binding. So what that means is, if you update data in your model, changes automatically get propagated to the UI. If you get changes in your UI, that data gets automatically pushed into your model. And so you can use that to make a lot of the kind of UI stuff really clean and simple. Obviously, one of the things with Angular.js is because the whole model is very declarative, and there's a lot of existing JavaScript components you might want to use. They have something called directives, which are like kind of widgets which you can incorporate other JavaScript libraries using.
It's not forwarding for me. No. Oh, here we go.
Okay.
So a lot of positives. Certainly, for me personally, about 2 years ago when I actually considered building fully fledged client UIs purely in JavaScript and trying to have this really proper separation of concerns between the user interface and what I was doing on the server, for me it just wasn't possible, right? I just don't like JavaScript as a language. It's a horrible, ugly little hack in a lot of places. And the library support wasn't just quite there. And so as Java developers, we were kind of forced to use JSF, Gwt, all these server-side templating languages, which is solving the UI problem in the wrong place. And so we've had to deal with this hack for years. And Angular, I think, is one of the first libraries that's come out to really allow you to do proper client-side templating, and it just works.
So one of the things that's nice in kind of HTML5 is the idea that you can kind of create your own attributes in your UI that map to constructs in your application or in your domain or whatever. And the problem is that very few browsers have enough support. And certainly if you ever plan to have clients who are like kind of established enterprise people with lots of money, which is a good thing to have as a client, a lot of those guys don't necessarily have modern enough browsers to deploy HTML5s, purely HTML5 web apps. But Angular.js ends up actually compiling your templates so it can construct these kind of things on the fly anyway. It also means you get declarative views, which are plain HTML with a few additions and nice templating.
So simple that even a CEO can go in there and actually make some useful additions to the code base without destroying everything, which is always a nice addition.
On the downside, we had some integration testing issues. So for a while, the Angular.js team were describing their kind of their framework, which they initially called Testacular, which rapidly got renamed for very obvious reasons. If you try and Google that keyword, which I'm not necessarily recommending you do, the results can be a little bit worrying at times. They got renamed to Karma. And then I think they've kind of backed off and said that's more an integration test framework, but for a while they were saying that's the solution to doing integration testing, and it doesn't really fit well with other applications. The other thing was, because we were doing a lot of kind of server-side push events, they have a bunch of things which rely on us being able to manually trigger a UI update, which is a bit unfortunate. Some of the If you're just using Angular to hook up to, say, a RESTful HTTP UI, that's not such a problem. But it was one that we encountered because we were very WebSocket heavy and push event heavy. And the other aspect is loads of people are familiar with jQuery. They know the problems. They know where it works well. And mapping over to the Angular world's a bit of a new thing. There's a learning curve. It's not quite that simple.
Who here uses jQuery or has used jQuery? Yeah, so it's sort of synonymous with Lambdas coming into Java 8. It's sort of synonymous with this kind of shift in thinking that you're going to have. So if you are a strong sort of jQuery and friends user, then moving to a model like Angular will require that same sort of mental shift. But I'll tell you now, it is absolutely worth it. What won't take you more than a couple of weeks to get the mental shift, and then you'll be off and racing.
Yeah.
So should we have a look at the score?
Yeah.
Overall score. Do the stars work at JFocus? They do? Yes. Cool. So we gave this 4 stars out of 5, and compared to hand-rolled JavaScript, it just is awesome.
Yeah, yeah. And I think it's also a framework that's a little bit more mature than some of the other client-side MVC frameworks. Mm-hmm. Seems to have a bit more traction, a bit more Java-friendly, built-in dependency injection, things like that. Good stuff.
No, it has been very, very good. So highly recommend if you're considering a new greenfield project and you've got to build a rich user interface and you don't want to use JSF or JSPs or any of that sort of nonsense, really, really take a look at this guy.
MongoDB.
From the good to the not so good.
So MongoDB is a NoSQL document store. Which means that instead of having a kind of relational model where you're putting tuples into effectively a set of tuples, everything is effectively a huge blob of JSON, which kind of under the hood turns into a binary format. It's scalable in the sense that it's really easy to do sharding and split up data, and it's also easy to get replication, so there's an element of fault tolerance if you get a server go down. A lot of the NoSQL databases have a different thing that they're good at, whereas Mongo is a bit more kind of well-rounded.
Yeah, it's a jack of all trades, I guess.
In some sense, yeah. And it is obviously the new database sexy. Everyone's talking about it. As Trish pointed out last night, they have just moved into being the 5th most popular database used.
Wow, that quickly?
Allegedly, yep.
That is incredible. That is a massive, massive change.
So it's ramping up in popularity.
Yeah, no, definitely. On the fault-tolerant front, it really did save our asses in production once. It's got a master-slave system, and the master that we had just completely ran out of hard disk space. And we didn't even find out until 2 days later, right? Because Mongo actually saved us. It immediately swapped over to making one of its slaves the new master. Everything was transparently done, and it wasn't until some old monitoring software kicked in and told me that our Linux box had completely fallen over that I'd even known that there was a problem that had occurred. So you do get this kind of benefit from some of the NoSQL solutions that have built this kind of fault tolerance in from scratch, whereas I think some of the traditional relational vendors have sort of patched it on as an afterthought. However...
So this is kind of the general architecture for deploying a scalable fault-tolerant Mongo deployment. So your client ends up speaking to a kind of Mongo service, and you've got a bunch of config servers that tell that where to look for data. Each chunk of data gets replicated between multiple servers, so if one of them dies, you're still good. And because the replication service ends up having a master-slave relationship, there's only one person writing, you shard that data out between multiple masters to support higher write throughput. So pretty standard sharding plus replication system.
Yeah, it all looks very good on paper. Who here uses MongoDB? We are going
a reasonable number of people.
We are going to frighten you shortly. Right, so we're going to talk about the positives first.
Yeah, so a lot of people have a situation where they've got a bunch of Java objects, they're already kind of doing an object-oriented modeling, the document-oriented modeling fits in with that quite nicely, the API is really good to get started, and it's also quite easy to get adopted, get a fault-tolerant system up and running, it's pretty low configuration in terms of if you're rolling out new services.
Yeah, it's a very low barrier to entry.
A very low barrier to entry. Yes. And it also can be quite fast. I mean, I put that asterisk there because depending upon what your workload is, different NoSQL solutions can be the right answer. And the answer to whether something's fast or slow is always, it depends. Go away and measure the alternatives. Yep. But it can be made to operate in quite a fast manner.
I mean, we have sort of millions of metric points streaming into our Mongo cluster, and we haven't even had to really think about looking into performance tuning it, or even looking at the performance characteristics. It's kind of just handled it out of the box, which is nice. We are actually a performance tuning company, so we probably should actually go away and do this properly. But it was nice that a piece of our architecture just kind of scaled under load, under the load to date. Anyway, negatives number 1.
On the downside, we were in a situation where we were looking at running secure connections between different servers. And we were also flipping between multiple data centers because we didn't want to be reliant on one data center falling over and taking the whole system down. So we kind of wanted a situation where different Mongo nodes could happily, securely talk to each other, right? So SSL is a good start for this, and Mongo supports SSL. But the free binaries for Mongo don't come with SSL support. To get an SSL-supported binary, you need to pay for a support contract, which is, not that great, but okay, so say you go along, it's open source, right? That means you can compile it and enable SSL support. So what happens? You compile it, you enable SSL support, you build an SSL-enabled binary, and then you say, hey, look, we'll get Mongo to build us a dev package so we can happily install that on the servers. And then the MongoDB script that builds the dev package goes off to the internet, downloads a version of Mongo without SSL support from their website, and puts that into the dev package that you've just built. What?
Well played, Mongo, well played. I mean,
well played.
It's a great technique to get more people onto their enterprise support, right?
Yes. So you need to end up, there's actually a guy's project on GitHub which does hand-rolled support for building proper packages from an SSL-enabled Mongo binary. And that's good. So it is possible, but out of the box, that's a bit worrying. And the other downside of not putting SSL support in the free version is that there's a bunch of kind of useful tooling and libraries for doing kind of administration and data updates and visualization and that kind of stuff, which just doesn't support the SSL version because they presumably haven't been able to test it or maybe aren't even aware of the SSL issue. So who knows?
Can't emphasize the security point enough. So for those of you who did say you are using Mongo, if you are using your Mongo cluster over the open internet or an unsecured connection, congratulations, you are now streaming your customer data and rep sets for anybody to look at. So I'll probably see some people scribbling notes to go and close that tiny, tiny security hole they have. But when we gave this talk at DevOps, I think, last year, there was like a frantic scramble to the exit as people sort of started realizing that, perhaps they weren't as safe as they thought they were.
There are also like data integrity concerns, which, I mean, we actually have had no production data loss due to MongoDB, but there are a lot of, there is a well-known scenario in which you can get data loss. And I think one of our coworkers, John, also produced a performance load test which got Mongo to reliably drop data as well for a while, which is a bit of a worrying thing.
So certainly when we're collecting metrics, for example, it doesn't matter too much because we're collecting millions of points, so we can afford to lose a few. But when we're collecting, the results of a performance analysis, which is critical to our customer, having the potential for that just to be lost is not great.
Yeah. The other issue with managing MongoDB clusters is it is possible to end up in a split brain scenario where two nodes both think they're the master of the replica set. It's not an easy scenario or a very likely scenario to hit, but it is possible to hit there with certain firewall misconfiguration issues.
Yeah, no, definitely. So everybody's either a secondary or there are multiple masters, and then all of a sudden everything just goes haywire. Not good. Negative number 2.
So yeah, the difficulty to automatically sysadmin is a real problem. I mean, we spent quite a bit of time trying to get chef scripts that would automatically spin up a complete replica set, and that was really quite a time-consuming thing where you needed to manually go in and log in and run something, and you had to automate that process was unnecessarily hard. We also have a kind of client-facing website, which is just WordPress PHP thing, and the PHP driver seems to be nowhere near as mature as the Java driver, and so there were some issues. Thankfully, we also knew someone who knew the person who maintained the PHP driver, so they were able to fix their issues. I can't remember the guy's name, but very, very friendly and helpful, but it would be better if those kind of issues didn't exist in the first place. The document-based modeling does tend to leave you denormalizing heavily, which is a trade-off you make. That's not necessarily a clear negative. It can be a bit of a win in some situations, but you really need to make sure that that's the right choice for your application, as it were. And obviously, there's a new query language to learn, so even though it's easy to get started, you have to get started, which is perhaps something you don't need to deal with from a SQL background.
And this is actually a bit of a killer, and it's true of a lot of NoSQL solutions. If you try and get your business people or your business analysts or whoever's used to writing a normal SQL report to try and get some real customer data out, and you tell them they need to write a map reduce in JavaScript, you just basically told them to go fuck themselves. And yeah, so it's a significant problem. So then you are forced as a development team to constantly build user interfaces and build custom reports and other user interfaces that your businessy type people can get access to the data, and that's very time consuming.
And the other thing is the poor time zone support, by which we realistically mean no time zone support.
Yeah, kind of important when running a cluster across the globe, kind of helps. So, the MongoDB scorecards. We're only going to give it 2.5 stars.
Yeah, I think you need to think about your security strategy. You need to think about whether the document modeling is right. You need to think about your replication, sharding type situation. There's quite a few things to think about as well.
Definitely. So, yeah, choose very, very carefully. I think we could equally argue if we had gone with some other NoSQL solutions, we probably would also have a long list of negatives and an equally low scoring, right? It's just an indication of the maturity of the space at the moment. Back to something a bit more positive.
So Vertx, it's a polyglot reactive programming framework. We've got message passing oriented, non-blocking I/O, WebSockets. We're totally buzzword compliant with Vertx. It's absolutely great.
1, 2, 3, 4, 5, 6, 7. Yeah, if any other speaker at this conference can beat 7 buzzwords on one slide, I'll be damn impressed.
But it is actually a very good framework. If you want this kind of message passing architecture, the non-blocking I/O, if you want the WebSockets, these were like a really good set of features for us, like a really good fit as far as Vertx goes.
Yeah, in a nutshell, for people who haven't heard about Vertx or who have heard about Node.js, you can probably see Vertx as Node.js on steroids. That is actually kind of better and gives you more flexibility because you've got more language choice and other bits and pieces. And it's not JavaScript. So on top of the kind of callback-based evented I/O stuff that you end up with from kind of the Node world, Vertx would also give you an event bus, which lets you do a lot of message passing. So this is quite good for kind of A, decoupling different components of your system from each other, and B, also maintaining that kind of non-blocking, event-driven style of programming throughout your application. Mm-hmm. There's one key aspect to this diagram which I'll just point out. Notice the shared event bus between the browser and the server. This is a very, very powerful and extremely useful concept that we rely on very heavily in terms of getting our push events quickly out to our UI and so on and so forth. I I couldn't believe it when it just kind of magically worked out of the box.
Yeah, that means you can wrap up a message from anywhere on your cluster, push it onto the event bus, and it'll end up in the user's browser,
Yeah.
just ready to be done.
Yeah. And again, to go back to the Angular.js point, that message or the data pops into the model with the two-way data binding that then automatically, enters into the actual user interface element that you've got there. So really cool stuff.
Yeah. So one of the key advantages of this approach is you end up with a complete no shared state concurrency situation, because everything ends up being message passing or callback based. If you've used kind of actors or CSP, that kind of thing, it's a similar vein of concurrency model that you're looking at. Event bus to the browser, as Martijn says, is a real win for kind of interacting between a complicated server application and also some rich browser-based UI. The community's great. The number of times we've just said, look, can we fix this, or can you fix this, or there's an issue or something small, absolutely rapid feedback,
yeah, and
very friendly, great community.
Yeah, really strongly backed by Red Hat now as well in particular, which is great. So if you're sort of concerned about its longevity or its long-term support, I think that's very much now being taken care of, which is great.
Yeah. And the polyglot thing is something we took a bit of an advantage of, because we used a bit of both Groovy and also Java, but they have support for Ruby, JavaScript, Clojure, Scala,
even
all
Ceylon.
Yeah, things no one wants to use. And it's also the aspect of the polyglot stuff is not just there's wrappers or binding, but because you end up with a message passing based approach, it's really easy for these things to interact. And you may well be using a component that isn't written in the same language, and it'll be quite transparent.
Yeah, it's really cool.
On the downside, we did have a few immaturity issues. So they had a big thing where they were moving from the 1.3 release to the 2.0 release, and they kind of stopped fixing bugs in 1.3 before 2.0 was out the door, which is a bit of a frustration. And the testing framework when we started off wasn't quite there, and it's been improved. It's got a lot better, actually. But there are things like that which are kind of immaturity issues in general, which I guess is one of the running themes of interacting with bleeding edge
certainly
tech.
Trying to get JUnit style testing written for asynchronous messaging style applications where you've got race conditions and things like this is very, very hard. And so you do need some sort of a test framework that's built in the very tool that you're using, which is Vertx in our case, to help support that. And for a long while, unfortunately, that support wasn't there.
Mm-hmm. They did also NIH the logging, which is a bit of an internal running joke about the number of technologies that end up NIHing their own logging.
Not that we've done that. Who here has written their own logging framework? Yeah, too many. It's just sad, isn't it? Java. Why?
And yeah, also the inter-machine event bus security was an issue for a while. We ended up having to wrap that connection up in VPN, SSL stuff as well. So.
Yeah, similar problem to Mongo, and we'll talk about this a little bit later as well. It's sort of a problem with all of these bleeding edge technologies and ideas. Things like security tends to be put in as an afterthought.
Yeah. So we gave Vertx a good 7 out of 10. If you've got the right use case, it's a great framework to use. It's not a kind of complete hammer that solves all your tech problems, but it's got a lot to recommend it.
Yeah, and it is absolutely exploding in terms of community support. The number of new patches, modules, languages being supported, all that sort of thing is absolutely going through the roof. So it's certainly one of my big picks for this year to really take off in the Java community. Chef, and we don't mean the cooking kind. Well, sort of.
Yeah. So Chef is a tool like Puppet that does kind of automatic server configuration. So there was a time when everyone was like, it's okay, we've got a sysadmin team, they'll deal with the servers. Yeah. And then you move to the startup world, there's no sysadmin team, you deal with the servers. Of course, Chef and Puppet as well are a big developer fights back type situation, where instead of configuring things, you write computer programs to configure things. This lets you roll out new machines very rapidly, and certainly in the past, I've tried to do a lot of kind of server configuration automation through a mass of hacky shell scripts.
Yeah.
And that works for a while, and then you realize that you've made a huge mistake and really, really regret it. And so things like Chef and Puppet are a great step in the right direction of having that kind of automated configuration without a pile of pain.
And it makes you treat your servers differently. So in the past, I always used to treat my servers as loved pets. I gave them names. They had a special place under my desk. They got some stickers on them. When you start getting into automating your servers and being able to bring one up within 5 minutes of the perfect configuration, you can start treating servers like livestock. Shoot them in the head, bring in a new one, which actually gives you a lot more flexibility in terms of trying to build out horizontally scalable architectures.
And yeah, on the upside of Chef, we found there were a bunch of Java JVM recipes, which were pretty good because we do a load of Java JVM stuff. It's also quite easy to do things like have a base recipe and then alter it and improve it and configure it. And also quite good for centrally controlling your configuration and rolling things out. And also there's a lot of things where if you end up using, I don't know, say shell scripts for automating server configuration, you kind of start off in a way where everyone does their own thing, and so having just a structure to everything and a convention-based approach is quite good.
But it gives you more flexibility than Maven does in terms of convention, by the way, so don't panic.
On the downside, Chef is incredibly inconsistent in terms of some of its commands. So, concrete example here. So Chef has a cookbook, so this is like a bundle of information. So say how you provision Tomcat might be a cookbook. It's got a role, so a role corresponds to, like, say, something that a server could do. I don't know, say your primary database server or something. And a data bag is like a bundle of information that can be used as configuration, or you can keep, encrypted data bags and have private keys. Now, all of these things are things which you want to upload and take from your local machine and put onto a Chef server. Same basic idea. So, if you want to upload a cookbook, you do Chef, upload, and then the name of the cookbook, or name the recipe. If you want to upload a role, you do role from file, and then the full path of the file. Now, two different ways, you think that's not the end of the world, but then there's a third way, which is the data bag way, which is to say data bag from file, and then, instead of taking the absolute path of the file, take a relative path of a file given another directory. It's like, what?
Horrible. So two things happened when we ran across the situation. One, I actually rage quit the computer and stormed out of the office one afternoon. And it's just all bewildering. I mean, knife data bag from file users, though that's actually 6 keywords in a command line. It is absolute insanity. We hope they're going to go away and fix this.
So one of the big negatives we found with Chef was so there's something called a librarian, which lets you manage dependencies and lets you kind of depend upon existing cookbooks that you pull in from outside, which we just didn't use at the beginning and then got to a bundle of mess on.
Yeah, and that was really our own fault.
That's partly our own fault, but it's also a shame that it doesn't kind of deal with dependency management out of the box and support this by default.
Yeah.
The other thing is, some of the situations in Chef it looks a bit declarative, you try and say that you try and kind of assert a file exists, and you get Chef to kind of deal with that for you, but it's not really declarative. So there's certain situations where it doesn't delete old config, and part of this really means that the idiomatic way of using it, in some sense, is almost to spawn a new box when you want a new configuration of things, because you might get old stuff left behind, and there's a few interaction issues when you roll out updates as well.
So my concrete example could be you go and install Tomcat on your machine in a certain directory structure. You then go, oh, that's a mistake. We actually want Tomcat in this other directory structure. So you update your Chef recipe. You go, Chef update on the client, and it brings down the second Tomcat, but it doesn't remove the first one. And then all of a sudden you start your machine up, and 2 Tomcats spring up, and you get the usual ports clashing and so on and so forth. So yeah, we've gotten to the habit where we do shoot the entire machine in the head and just bring up the thing from scratch.
And the other thing is as well, there's still a very big learning curve to these kind of things. So if you're a developer who's taking on a little bit of this kind of work alongside your normal role, bear in mind there's a big learning curve to that kind of stuff.
Yeah, I mean, you're going to have to learn a lot more about your operating system, networking, things like, configuring IP tables. You're going to have to learn Ruby.
Yeah, you have to learn Ruby.
Yeah.
Maybe we should have said that earlier.
We should have said it earlier. You have to learn Ruby.
So yeah, it is way better than shell scripts. I think one of the things is we haven't tried using Puppet particularly, and I think a few people seem to be moving more in the direction of Puppet rather than Chef these days. But still, it's a massive win over manual configuration. It's a massive win over rolling your own nonsense. But yeah, there are still issues.
So I mean, we had a really small team, and the number of servers that we have up and running and that we're able to deal with, we can actually scale it, which is something that just previously wasn't possible. So I highly recommend that. So we've got a quick 5 minutes to wrap this up. So we're just going to sort of wrap up some common themes we've discovered along the way. So three kind of themes that we picked up from the technologies we picked and how they ranked. Definitely, you're going to have to deal with immaturity. Okay, so if you're expecting not to have to contribute back or deal with the occasional bug in things, then this may not be the choice for you. There's certainly a lack of full-stack tooling. So if you're used to your Eclipse IDE doing everything for you for a particular framework or library, again, in some cases, you're just not going to get that. And a lot of these bleeding-edge technologies just haven't been designed to play well together, right? There's no standardization in this space. There's no Java EE spec. So, sock.js had some bugs, which therefore broke what was happening with our shared Vertx event bus, so on and so forth.
So, let's talk a bit about the brave new world.
Yes, come and join us. Isn't that nice? Valentine's Day is coming up.
So, we currently have this kind of interesting relationship with technology vendors where it's, an exchange of money for technology. So maybe they're like the sleazy guy on the top, or maybe they're like the friendly, colorful hat-wearing people. Both ways there's a situation where you're paying people money in exchange for saving time. Yeah. But it's not like these kind of things are a complete bona fide win. It's not like there's no cost on your behalf, no integration cost, no kind of situation where you get a completely smooth experience. Yeah. And maybe you might be paying quite a lot of money for consultants to come in to support a technology, and they might be Martijn immediately after graduating from university.
I was a consultant for a consulting firm I shall not name. They're very famous for hiring lots of graduates and beating them to death for 2 years. And we would go into client sites with how to code Java in 24 hours under our arms and be charged out at 20,000 krona per hour to solve their clients' complex technology problems. So it certainly wasn't the engineers or the technologists or the project leads that were going in and helping solve problems. They were the worst of the worst, which was, kind of me. So yeah, I think we've kind of covered this. What does your support contract really actually give you? Ask yourselves and your bosses this, because I tell you what, you're probably not getting an awful lot.
So we've buzzword pro'd ourselves, and described, kind of a vaguely kind of approachable model that seems to be beginning to get traction in some places, which we would say is a la carte open source. So this is very, very popular with, as we say, zero budget startups who can't afford those kind of ridiculous support contracts.
Exactly.
And a lot of the kind of open source projects that you see kind of popping up now end up being commercially funded technology platforms. So something like Angular ends up being spun out of Google, and they employ the developers, they commercially fund the project. There's a future, but they're not doing it because they're expecting a long-term support contract back. They just want more people doing browser-based development and less kind of tie-in to desktop platforms. These are also things that have really strong community support. So Vertx is a really good example of this, where the community is just great and really friendly and happy to solve problems. And you kind of get more well-rounded benefits. And it can also be sometimes, frankly, a lot easier to change things in a kind of a la carte open source world if you're willing to play ball with the community.
Yeah, because instead of dealing with first-level support over the phone, you're actually dealing with the real engineers on a mailing list, or you're submitting a pull request. The conversation is close to the code, and stuff just gets fixed a lot faster, and new features come in a lot faster as well. So to wrap up very quickly, if you are going to do the a la carte thing, you have to be prepared to be part of the community. So we spent roughly 20% of our time committing patches back upstream to Vertx, to the MongoDB driver, open sourcing a really kick-ass Maven release plugin, which actually works. So copy that URL later. Doesn't run the tests 4 times in a row, which is nice.
Yep.
How you can do this yourself at home instead of being, bludgeoned with these large enterprise technology stacks. Take a small project, something that's behind the scenes, something like an administration CRUD screen for some sort of client-facing application you've got. Start using a new technology stack. Try it out. Don't ask your boss. Don't ask anybody. Just do it. Okay? Always ask for forgiveness, not for permission. And when people say back to you, oh, they wouldn't like it, the committee won't approve of it, go find out exactly who those individuals are. So don't be afraid of this kind of organizational them thing. Go find out if it's Sven or Peter or Richard or Amy or Cecilia. Go talk to them and really have that open debate with them and say, hey, why can't we try this new technology? It might actually do the whole business some good. And yeah, you can be like these guys, on the bleeding edge, fighting bad enterprise stacks, and yeah, hopefully winning in software development. So we've perfectly timed this, so there's no time for any questions. Yes! 2 times in one day. But do come up and see us afterwards. We'll just be off to the side of the stage. And thanks again very much for listening, and we hope you enjoy the rest of JFocus.